Hello everybody! Today I'm going to continue with the wolfram language tutorial and I'm going to talk today about loops. So as I'm sure you all know, sometimes we need to run over a block of code a couple of times. So in this case we want to use loops, and the wolfram language has a few different kind of loops. So we will start from the simplest form, the do loop. The do loop is a function that will receive two parameters. The first parameter is the expression that we want to loop on, and the second parameter is a list containing values that will define how the do loop will act. So in this form, with only one item as an integer in the second parameter, we can ask the do loop to run over this expression 4 times. Okay, so if I will run this, we will have the word hello printed 4 times. With the second parameter that has a symbol at its first place, we can tell the do loop to use an indexer that will increment each time the loop iterates. And so in this code, we will print 4 times, and each time we will multiply the number 4 with the incremented indexer. So let's see the result. Okay, so by looking at this result, we can understand that the first iteration sets I to be 1, which is not common in most programming languages, which most of the time starts counting stuff from 0. We can show it if I'll remove x and just print out I, so we can see that the first iteration sets I to be 1. In this line, I'm providing the do function more details on how I want the indexer to act. So I want it to start at 2 and to continue up until 10, and the step size will be 2. So I will be incremented each iteration with a step size of 2. So we can print the result and we will see that it starts at 2 up to 10, including 10, and the step size is 2. In this line, we can see that I can provide not only one indexer to the do function, I can provide another indexer. This time I used I and k, but you can choose your own symbols. And the expression that we are going to repeat is a print function that will print i's value and will concatenate it using these symbols to the value of k, with an empty space between them. This way we can see that for each iteration of I, k is going to run from 1 up to including 4, and then after k's final iteration, I is going to increment and k will run from 1 to including 4 again. So in this way we can achieve something that works pretty much like a nested loop. In this line, I wanted to show the usage of procedures with the do function. I mean, running a couple of expressions in the same line. So here inside the do function, I am printing, and then I am assigning t the value of this expression, and I will run this procedure 3 times. Another kind of loop that the wolfram language provides us is the until. Until works something like a reversed while loop. So we have here a statement that we will check each iteration and an expression that will run each iteration. And this loop is going to run until this expression will be evaluated to be true. So we are assigning 1 to the symbol n, and then we are incrementing n each iteration and printing n times 2 each iteration until n is going to be larger than 10. Here is an example to the while loop. While loops are very common and are structurally similar to what we saw in the until loop. The first argument of this function is the statement that we will check, and the second argument is the expression that we want to perform each iteration. And contrary to the until loop, the while loop will continue iterating as long this statement will be true. So here I am assigning 1 to n, and each iteration I will increment the value in n, and I will be checking each iteration if n is still smaller than 4. So when n's value is going to be 4, this statement will not be true and we will exit this while loop. We can use the break function inside a loop if we want to provide a special case other than the statement that we are checking each iteration. Here I'm using the if function to check if n is equal to 8, and in case this statement will be true, we will exit the loop in this case. Any other case, we will print the value of n. So here we are initializing n with the value of 1, and because of this statement we can expect n to be printed from 1 up until 7. Another way to control loop execution is the continue function, which if it gets called inside of a loop, it stops the current iteration execution and goes directly to the next iteration of the loop. So in this case, we are initializing n with a value of 1, and we are running the while loop as long as n is smaller than 10, incrementing n each iteration, and checking with the if function if n is equal to 5. If so, we will continue to the next iteration, but any other case, we will print the value of n. So in this case, we can see that we print from 2, and we start from 2 because the first thing we are doing is to increment n. And when n was equal to 5, we skipped this print function, and because of this, 5 was not printed. Here we can see the famous for loop. We can see the for structure is starting point, test, incremation, and a body that we will iterate on. So in this case, we are initializing I with the value of 0, and we are testing if I is smaller than 10. If this statement is true, we will run this expression, and we will increment I. So here, in each iteration, I am printing the value of I being doubled, so this is what we get. So in this line, we can see that we can use procedures in the start expression, checking each iteration if I power of 2 is smaller than 10. If so, we will run this procedure and we will increment I. In this example, I just wanted to format the for loop a little bit to resemble what it looks like in most programming languages, and to show a common loop exercise that most students go through when they learn to code. This is how to print this kind of triangle. Notice the usage of the string repeat function to repeat this string I times. In this example, we will see a more unique function that the Wolfram language has. This is the nest function, which resembles the usage of recursion. Yes, this function is applied n times to this expression. So I've defined a very simple function here. I know we didn't talk about functions, but this is the way we can define a very simple function that will receive a parameter and will return the value of this parameter added with the value 1. So in this line, we are using the nest function, giving it f. This is our function's name, and this is the value that we want to give it, and this is the number of times we want f to be applied to the expression. So here we will receive a number, but because it's a little bit abstract, I've written this line using a symbol instead of a value, so we can see exactly what is happening. So 8 is the result of this line, and here we can see what actually is going on. We are sending z to foo, and then we are sending this expression again to another foo, and then sending this to foo the third time. So I hope it helps to understand what is going on. Fixed point is another unique function. This function will go on until two successive results it gets are the same. So in this case, we are running fixed point with this expression and this value. So we are sending this value to this function, and this value is going to be assigned to t. Then this function is going to run this procedure. It's going to print the value of t, and then it will halve it and floor the result, so we can have an integer, halving this value again and again and again until two successive results, and then this loop is going to stop. So here is the result. Scan can be considered as a iterating mechanism more than a loop, but still I wanted to show it. With the scan function, we can provide it a function and a list, and the scan function will evaluate this function to each element from this list. So as you can see, this expression has a special syntax that means that this whole expression is an anonymous function, means it has no name, and scan will apply for each item in this list, assigning this placeholder the value of the current item. So I will run this, and we can see that each iteration we are printing the corresponding value with the power of 2. Here I will show a more specific usage of scan, but the function is pretty much the same, just without the power part. What I wanted to show here is what happens when we are scanning over a list of lists. As you can see, this is a list containing a couple of lists. So in this form, what we are going to print each iteration is the inner list. Okay, so let's see it. So first we are printing this, and then we are printing this, and then we are printing this. So if we want to change the way that scan works, we can provide it another argument telling it what level we want this list to be applied to with this function. Let's run this and we will see. So in this case, if we provided just an integer value, we can see that the scan applies the function to each of the items inside the inner list, and then the whole inner list is 1, 2, and then 1 and 2 as the list. So in this case, it is said that it scans down to level 2. But if we want it to scan only to level 2, we can put the curly brackets around the level definition. And in this case, it will apply this function only to the innermost items, like so. So another very similar function is the map function, which maps this function to each of these items. So I can run this, but first I will just provide a simple definition for the f function. Okay, so in this case, if I will run this, we can see that f has been applied to each of the items, and the wolfram language provides us a shortened version of the map function with this symbol. So with this syntax, we will get the same result, having f being applied to each of these items, like this. Although very rare in actual usage, the wolfram language has a goto function, and goto uses a label, and if we provide goto a label name, it will jump to the place where the label is defined at. And so here what we can see is that we can create a loop-like behavior using no loop at all. So what happens here is this f is a function, and inside this function we are wrapping everything inside a module. I will explain about modules and function in the next lesson. But anyway, this module defines a couple of local variables and marks the beginning with the label begin. Here we have an if function that checks this statement, and if this statement will be true, we will jump to the end label, unless we will continue running this statement and then this statement and then going back to the beginning label, therefore giving this f function a loop-like behavior. But as I said, this is very rare, not only in the wolfram language. Most programmers prefer not using the goto mechanism because it really complicates stuff that can be written in a different way. So I will run it just to show that this code performs as expected. I copied this code from the Wolfram Language Documentation Center, and you can read more about it here. And to finish off this video, I wanted to show the timing function that can be used to measure the execution time of expressions and of course of loops. So in this case, we are measuring the execution time of the do loop printing hello 100 times. Okay, so we will receive the result in this form. Okay, so I really hope you enjoyed this video. Please consider giving me a like and subscribing to my channel, and I hope to see you all in the next video. Goodbye.